Okay, put your phones away, please. Eric? You can if I take it. That's easy. Okay, you guys, do you remember how to plot points? Okay, you are measuring your distance from the origin. R is the distance from the origin. Theta is the angle which you rotate. And so if I had a -1 and pi over 4, okay, you guys? If you're going to talk, I'm going to ask you to leave. Fine. I'm going to rotate 45 degrees, and this is the ray. I want the radius from the origin that's -1. Do you remember what we did with the negative? We went the other way. So the answer would be this way, where this length would have a length of 1 unit, so it's -1. It's going the wrong way. And there's many ways you can write, you can find coordinates for this point. It's not a big deal. Now, we're going to remember the basic things about polars. And everything we do on this, no, come on. If you know this, you should be just fine for a polar. I haven't had a polar since 2008, so I'm thinking that there may be some sort of polar on this exam. So there's my circle. And I'm going to draw the radius. This point on the circle is x comma y. This is r. And if we drop this down, this length here is x, this length here is y, and this is theta. Now we know this from parametrics. It's the same thing in parametrics, which is why I was thinking of even going into the vectors today, doing problems tonight, or it's kind of up to you. I know Mrs. Hersman's going to do polars today and vectors tomorrow. But tonight is the study session, so it would be on polars and parametrics vectors. And then I have to see what my schedule is. Oh, I should have to run and get the schedule. I have schedules for you guys. Okay, so what's the cosine of theta? What's the cosine of theta? X over r. So knowing that, we know that x equals r times the cosine of theta. Because they might ask for dx. They might ask for dx d theta. So you have to know this. And by the way, you get points for this. We're going to do some problems, but first I'm just giving you the basics of vectors, of polars, sorry. And it's the same with vectors. If you're talking about parametrics, it's going to be cosine of t. So it's exactly the same thing. So what's the sine of theta? Y over r. So if you solve for y, it's equal to r sine theta. Okay, guys? It's alphabetical. Cosine comes before sine, x comes before y. So that's, I don't have to derive it every time I can remember it. Okay? And you're going to have to know, well, what's true about x squared plus y squared? You could put these in there, and you're going to get r squared. That's a circle. And what's true about the tangent of my angle? Any of these things we could possibly have to use. What's the tangent of that angle? Y over x. I can even think of a problem right now because we did them last night. We did every single problem last night. And it won't hurt you to do them more than once. If you have already done them, that's okay. You can do them again. You have to know some basic graphing. You have to know what r equals 2 looks like. What is that? It's a circle of radius 2. It's centered at the origin. If you have to know what theta is equal to pi over 4. I think I have that right. Then that's just a line at 45 degrees. Because he could ask this. This one I've seen. Okay? You have to know r equals like the 2 sine of theta. Let's do cosine of theta. If r equals 2 cosine of theta, I need to know where that is. Okay, Eric, you're not going to know this. I really think this is going to be on the exam. I thought it was going to be on the exam last year. It's been 5 years since it's been a free response question. Now, here's the thing. The multiple choice you take first, right? If you do not see a polar in the multiple choice, you know it's an FRQ. It has to be there. Maybe once you get used to these, you're going to say, I kind of hope there's a polar because they're really not that hard. If you know what I'm talking about here. Do you guys remember what this graph looks like? Well, you know what you could do is put in theta is equal to 0. Then r is equal to 2 times the cosine of 0. So what I mean, you have to know the basic graphing. What's the cosine of 0? It's 1, so this is 2. So sorry, my line's a little bad, but there it is. Then I'm not going to rotate anything. I'm just going to stay right here on that axis. Then let's rotate 90 degrees, pi over 2. Then r is equal to 2 times the cosine of 90 degrees. What's that equal to? Nick, do you remember? That's 0. So if I rotate 90 degrees like this, I'm going to be up on this axis, but I'm not going anywhere from the origin. So this is the top half of the circle. I just ought to remember that. That's a circle. And when does it finish up? Not when theta is 2 pi. What's theta going to be equal to here? Here's theta is equal to 0. Then when I finish up here, if this is pi over 2, what's this going to be? It's going to be pi. So the period is pi now in polars, which who would have thought of that? So what if I have r equals 2 sine of theta? Well, so when theta is 0, the radius is 0. So you're going to start at the origin this time. When you rotate 90 degrees, the sine of theta is going to be 1, so you're going to be up here at 2, something like that. So let's go do this. Here's how I remember, because these are the basic things that you'd have to know. If it's a sine, it's on the y-axis, because y is equal to r sine theta. And that's just a way to remember it. And this is 2 cosine theta. And remember, cosine is the x-coordinate, so it's on the x-axis. What is the radius? If this is at 2, that's also the other deceiving thing. The radius is equal to 1. You think it's going to be 2. I don't think so. I need a pass. Okay. Okay, so that's the basics there. And then I'm trying to think. The other thing you have to know is finding dy dx. And again, it's like the parametrics. Do you remember in parametrics, dy dx is dy dt divided by dx dt. That's why I kind of thought to do them together, because that's the parametric piece. And so what's dy dx in polars? It's dy d theta over dx d theta. Remember, now what's dy dx? Dy dx is the slope of your tangent line. If you don't know how to write a tangent line, come in and see me, because you have to know how to do that. This is the slope of the tangent line. So let's find dy d theta so you can realize it's not as easy as you think. So if y is equal to r sine theta, what's dy d theta? By the way, you get the point for writing this. And then you get the point for doing this derivative right. I have to use the product rule. So it's r times the cosine of theta plus the sine of theta times what? The r d theta. So that's usually worth a point. And because it's free response, if they ask you to evaluate at pi over 3, you don't have to find the value, but you do have to put in pi over 3. So what if x is equal to r cosine theta? I don't memorize this. I just figure it out. So what's dx d theta? R negative sine of theta, that's too much to memorize, plus the cosine of theta times the r d theta. Now, those of you here last night, have I missed anything? Anything else I talked about? I think that was it. And that's all you have to know about polars. then yeah, that's exactly what we're going to do. But I can do the vectors. There's not much to do with vectors. Yes. You have to take the derivative. We'll do a problem. You have to know what r is. Oh, yes, thank you. Area under a polar curve is 1/2 r squared d theta. That's easy. You get a point for that. And from theta 1, that's the hard part, to theta 2. Now do I have everything? Arc length is really more with the vectors. So you want to do some problems right now, or do you want me to do the vectors right now? Problems, okay. Now, I've got this. You have these problems. Some are on salmon, and some are on the blue packet you had. And then what I'm going to do is, for next week, we're going to be doing the Taylor polynomials and all the convergence tests. I will run multiple choice questions for you and the free response questions. You have them already, but I will rerun them. What do you want me to do? You may not know where they are. So I'll rerun them, and then we'll be working with those problems next week. 40% of your exam is BC. You'll have an Euler. You'll have arc length. No, it's pronounced Euler. Yep. Okay. What else do we have? You'll have some easy parametrics. You're going to have a lot of convergence tests, a lot of geometric series, and maybe some improper integrals, and you'll have partial fractions. That's what I've seen when I look through the multiple choice part of the exam. Oh, and you'll see L'Hopital's rule. That could be embedded in the free response as well. Okay, so Ellen asks, how do I find dr d theta? See, there's r. Now, here's the hard part. This is question 4. It is not a graphing calculator problem. So we have to find the area of the shaded region. If I don't know how to graph points, I can't figure out what the angles are. The domain is 0 to pi. Okay? So r is equal to 1 minus 2 cosine of theta. So what is r of 0? I want to know where I start. It's 1 minus 2 cosine of 0. Okay, so r is equal to 1 minus 2, which is negative 1. So I'm going to rotate 0 degrees. I'm on this line, but the radius is negative 1. So guess where I'm at? I'm right there. See what I'm talking about with knowing how to graph things? Then the other thing is I want to find out where this is. Now, what's r equal to here? 0. So 0 equals 1 minus 2 cosine theta. I don't think it's going to be pi because it says this whole thing here is a picture from 0 to pi. Pi should be over there. So negative 1 equals negative 2 cosine theta. That's right. So the cosine of theta is equal to 1/2. And I'm going to draw my triangle. And this is 30 degrees. This is 2. This is 1. This is square root of 3. What's my theta? 60. So it's pi over 3. Did you guys see that? Because you're going to get a point for that. Okay, write an integral expression for the area. Well, that's easy. It's 1/2 r squared, 1 minus 2 cosine of theta. You do have to remember it's squared. Can you remember that? All those areas are squared, if you think about it. D theta from 0 to 60 degrees, or pi over 3. Was that bad? Finding the angles is tricky. Because 0 to pi would be all of this. Pardon? Because the formula is 1/2 r squared d theta. If you want me to show you why it's r squared, I will, if that will help. Well, if you forget, it's useful. Now, that's 2 points. 1 point for knowing it's r squared, then 1 point for knowing the 1/2 and the 0 to pi over 3. So if you got just this part here, forgot the 1/2, you're still going to get a point. At least that's why I'm interpreting it. And why is it that way? If I want, this is a circle. I want to find the area of this little piece of pie. So it's theta out of how many radians? 2 pi. Part of a circle, pi r squared. So the pi's cancel, so it's 1/2 theta r squared. The theta is what's going to get really small. So that's my d theta. Now do you see why it's r squared? Because it has to do with a circle. If I can remember that, then I can remember this. Okay, that was easy. Then it says find dx d theta and dy d theta in terms of theta. Well, x is r cosine theta. So x, I like to put the r in. You could differentiate here. My personal preference is to put in the 1 minus 2 cosine theta. I'll slide that up, times the cosine of theta. You know what? It's just what I just did on the last one. Take the derivative. So what's dx d theta? Trevor, what's dx d theta then? David? It's the first one? Yeah, you should do it. Watching isn't going to do you much good because it doesn't, you don't internalize it when you just watch. And what's the derivative of cosine of theta? Negative sine of theta. Plus cosine theta times the derivative of 1 minus 2 cosine theta. Okay, Trevor, you should be doing this. What's the derivative of 1? It's 0. Derivative of minus 2 cosine theta is plus 2 sine theta. Is that right? Because the derivative of cosine is negative. Okay? Jared, you should be doing these problems, not sleeping. I did this a long time ago. Can you do it on your own? Can you find dy d theta? No. The one you did? Not that one. That one's a tough one. We haven't done that one. I know that. Is that one. Does look alike, don't they? They do look alike. I want you to have confidence. And you won't have confidence if you don't practice. I certainly don't want to get up and play the piano in front of anybody. I can play. I can read music. But unless I practice, I'm not going to be able to do it. Same thing here. So if you think that you can walk into this exam without practicing and get a 5, think again. Notice the calendar there. I'll put one up for you guys. It's not very long. So you need to be doing problems. You need to do them. I would do every single polar problem that I've given you, which forces you to go to the B's. But I gave you a handout on it. I could run them again if you want me to. No, but if you want practice on the polars, that's the only place for me to pull the problems. I've looked at the Princeton review materials. They're not challenging enough. That one I haven't seen, but I've looked at the Princeton one, and they're pretty straightforward problems that you will not see on the exam. I was actually disappointed with it. Plus, they have topics that have been thrown out. So then you got to know what's on there and what's not on there. Here's r sine theta. Where's that movie? Okay, so y equals 1 minus 2 cosine theta sine theta. Well, guess what? We're going to do the same thing, right? Is this hard? This is worth 4 points, you guys. This is easy. Dy d theta, but it may not be easy if you haven't practiced it. The problem is you want to do as many problems as possible so that when you get in there, you recognize what's being asked. Because once you don't know what's being asked, that's when you get nervous, and then you shut down. Well, at least that's what I do. That's the cosine of theta plus sine of theta. And that's the same derivative, so it's 2 sine theta. And this was on our test. It was on our polar test. So you have seen it. 4 points for that. You get 1 point for doing this and this. That just asks for the derivative. That's it. Not yet. Not yet. And this part of the problem is asking for this. It's asking for the derivative of r, dr d theta. That's worth a point, and then a point for your final answer, this one with that one together. So now we've got 6 points out of 9. This hasn't even been tough. And the next part's not even tough either. Write an equation in terms of x and y for the tangent line at the point theta equals pi over 2. We have to find, well, let's write down what we need to know. We want a tangent line. So y minus y1 equals mx minus x1. Well, yeah, but we have to find it because it's not going to be the same next week, in 2 weeks. 2 weeks. 2 weeks from tomorrow. Stress levels should go up. Okay, so what's the y1? It's r times the sine of theta. And theta is equal to pi over 2. Okay, so it's going to be equal to r. R was 1 minus 2 cosine theta. So what's r of pi over 2? It's 1 minus 2 times the cosine of pi over 2, which is what? Okay, guys, you know? Negative 1. So it's negative 1, and the sine of theta is 1. That's the y value. Isn't it negative 1? Cosine of 90 degrees? Oh, wait, what's the cosine of 90 degrees? I'm getting mixed up. I'm tired. It's 0. So it's 1. Okay. Then we have to do x. X equals r cosine theta. We already know what r is. What's r? R is 1, right? What's the cosine of pi over 2? Sine of pi over 2 is 1. What's the cosine of pi over 2? What's the cosine of pi over 2? 0. So x is 0. And then Ori says he remembers the answer, but that doesn't help. This is a 0. This is 1. And now I got to find the slope. How do you find the slope? Right. dy dx is dy d theta over dx d theta. And they picked nice numbers. What did they do that was so nice? Okay, let's look at dx d theta. What's the cosine of pi over 2? That's 0. So guess what this whole term is? That's 0. So I just have to put in pi over 2 here. So it's 1, and then it's times minus the sine of pi over 2. What is that? That's 1, so that's equal to negative 1. That's what dx d theta is. Yep. dy d theta, and I said the cosine of pi over 2 is 0, so this whole thing goes away, which is nice. And this is 1. This is 2 times 1, so this is equal to 2. So it's 2 over a negative 1. So it's y plus 1 equals, oh no, sorry, y minus 1, my mistake. Y minus 1 equals negative 2x minus 0. You just have to know the polar stuff, then it's AB material. The next one we're going to do, we haven't done before, unless you were here last night. Yeah, we're going to do it again. You should see if you can do it ahead of me. Well, let's check their points here. We had both of these, so we got a point. We found the RD theta correctly, so we found a point. And then we don't worry about simplifying it. Just put them in and leave it. And 1 point, 2 points for your answer. So that's 4 points right there. So that's 6. Finding the values of x and y is not hard. But if you don't know x equals r cosine theta, then you can't do that. You're done. You're absolutely done. It's over. So you have to know this one board. That's what you have to know to do the polars. I don't think I've forgotten anything, but I could be wrong. Wouldn't be the first time. And dy dx is negative 2, so we got that, and we got that. We got full points, 9. And it wasn't that hard. So at least you should be able to get 6, even if you mess up someplace. Okay, how about this one? This one's tough. A is the hard part. We never got to this problem. Might have been. Okay, Griffin, you should be working on something. I know, but if you know what we're doing, either redo the problems or work on something you like the multiple choice. Remember, you're supposed to be working on 2008 multiple choice. Y minus 1 equals negative 2x. A is worth 4 points. A is the big point getter in this problem. They give us the angles. That's kind. This was what year? This was 2007, so this is a graphing calculator problem. No. Good question. You can always leave it in point slope form. I need that shaded region. Now, have you thought about it? I would like to give you a chance to think about it. 2007, and it's a regular 2007. So 2008 may be form. No, they might have done it both years. So if we were to look at the multiple choice for 2007, you would not see a polar problem there. And that would have been a clue. I don't know what you can do during break. Probably can't go and look at anything. But that's a clue that you're going to have a polar. Have to have a polar. So I need to find the area of that shaded region. Now, people who were here last night know how to do it, but how about those of you who weren't? I have to break it into 2 pieces because I have 2 circles there. Well, actually 1 circle, if I realize it, and the other one is a limicron. What if I did this? Let's just break it into pieces. That's easy. That's half my circle, right? Here's the circle, r equals 2. So it's 1/2 pi r squared. That's just geometry. It's perfectly allowed. That's that part. But now you got to get the other pieces. You've got to get this piece, and they are nice. They tell us what the angle is. This is 2 pi over 3. What is the reference angle then? How many degrees is this? Let's go to degrees because we understand that. 60. So how many degrees for this little piece of pie here? That's 30, right? And if I do the other one, because of the symmetry, that's also 30. So this little blue purple part is 60 degrees out of 360. If you want to do radians, be my guest, but I'd rather do it this way. Times pi, it's still the same circle, 2 squared. So it's 1/6 of 4 pi, or 2/3 of pi. That's just the circle part. Could you have integrated it? Yes, you could have used a polar curve, but I used the geometry. That's where the point, or is that where, I think that's where the point. Now we have to do this strange area right here. But we have the angle, so this is easy. This is a graphing calculator problem. So now I need the green part. That's part of this circle, but I only want from here to here. Yeah, it's a limicron part. So you want to start at 2 pi over 3, rotate around on that curve, which is this goofy looking curve, to this. That's 2 pi over 3. That's 4 pi over 3. Yes, we did, for those who were here, but not everybody was here. Because not everybody can come at night. So it's 1/2. They gave me the angles. That was nice. And it's r squared. What's r? Now make sure you're in radian mode. I believe that's 2 points. That over there is 1, and then 1 for the final answer. You know you've done a problem too long when you know the scoring rubric. And there it is. 4 points for that. How is what? Limicon. Limicon. I don't know if it's a hard C or soft C. Okay? So you could get that. Okay, ready? Now, oops, I went a little too far. Wait, undo. I slid the wrong thing. There. Okay. particle moving with non-zero velocity, it's just scary sounding, along the polar curve, the limicon, has a position, x and y, when theta 0, t 0. The particle moves along the curve so that dr dt is equal to dr d theta. Find dr dt at pi over 3. So I want to find dr d theta because that's dr dt. dr dt equals dr d theta at theta equals pi over 3. Well, what was r equal to? Or I want, yeah, it's r. R is equal to what? 3 plus the 2 cosine of theta. What's the r d theta? Derivative of 3 is what? So it's 2 times the cosine of theta, but the derivative cosine is negative. So it's negative 2 sine of theta. And we want to do this at pi over 3. Now, you could just leave it negative 2 sine of pi over 3. Because what's true about the sine of pi over 3? Is it positive or negative? It's positive. So that this is always less than 0. So if dr dt, because it's the same as dr d theta, is less than 0, then what does that tell you the point's doing? The radius. If dr dt is negative, the radius is getting what? Smaller, so the point is moving where? Closer to the origin, or the sun. I think we're moving farther away from the sun, but the center. Well, right now it feels like we're moving farther away since I don't remember April 23rd with snow on the ground. Okay? I know, finally. It will be much out there. That wasn't too bad. I know, I know. Okay, so let's see what we get for points there. Now, I forget this every time. You really should say, since the radius is positive, because if the radius is negative and dr dt is negative, then it's moving away. It's going the other direction. I don't know, I got to think about that. I don't know how picky they're going to be about that, because I can't believe people did that. Oh, by the way, I did that the hard way. I did it by hand. You can use your calculator, sometimes I forget. That's 3 points. So now we're at 7. This has not been difficult. It looks bad, but it isn't. And since you have a calculator, just put it in your calculator, but I know it's negative. Then what's C? C is, I want to find dy d theta, which is equal to dy dt. I want to do it at theta equals pi over 3. What's y equal to? It says, what does it mean? It means the particle's moving closer to the origin. So just find dr d theta, which is really easy. And you can put it on your calculator, which I can put this on my calculator, but I'll do it by hand. Okay, so what is it? It says r sine theta. And y is equal to 3 plus 2 cosine theta sine theta. And actually, you could just put it on your calculator with n derived. And theta is equal to pi over 3. Do you want to do it by hand? Or do you want me to just look up the number? Because I don't know what it is. So dy dt is, the interpretation is a little trickier. You just have to think for a second. They actually did it there. It's a half. I have to know if it's positive or negative. Because if dy dt is positive, then what's true? Now this is y. This is not r. What's the point doing? Matt, what's the point doing? This is the y value, not the radius. The radius is always measured relative to the origin. But the y value is not. It's relative to the axis. So if dy dt is positive, the particle is doing what? It's going up or away from the x-axis. Because y is also greater than 0. That wasn't too bad, was it? And you can go through the multiple choice. You're supposed to be going through 2008. there weren't any polars in 2008 because in 2008 there was a free response. There was a polar one. Mm-hmm. Tell me to find it. I got it. I think I have it. That one? That one. That one was tricky. Now, the Form Bs are what they take internationally, and they're usually a little bit harder, but it's really not that bad. You have to think a little bit more, though. So, and actually, and this is a graphing calculator problem, and they're asking for the area of R. Well, guess what? That has nothing to do with polars, because you have the Cartesian coordinate one. So we're going to, well, it says, careful, with respect to x, which means now I have to do this and this. I have to have two integrals. Now let's review this because it's been a while since we've done this. The area under a curve, if I look at my slice, the area is equal to the integral. That's the y coordinate minus 0, because the x-axis is the other one, and it's dx. Okay, you guys, are you paying attention? This is reviewing of areas. So now what I have to do is this little circle that's shifted over. I have to solve for y in terms of x. That's algebra. So I have x minus 1 squared. I did this really quickly last night. I want to solve for y. So y squared is equal to 1 minus x minus 1 squared. You can't make it x squared minus 1 or plus 1. And then you square root it. I want the positive one because I'm above the axis. That's the y that goes in over here. And y has to be in terms of x. The second one's a lot easier. Now, where are we going to integrate that to? They tell us that this intersects at 1, 1. So the x starts at 0 and goes to what? 1. It doesn't say to integrate it. It says set up an expression. Now that's for just this little piece. Guess what? I've got to do it for the other piece. So it's the same type of thing. It's this y coordinate minus 0. It's still the same formula. So guess what I have to do? I have to solve the other equation for y, but that's easier, isn't it? Y squared equals 2 minus x squared, and then you square root. I'm taking the top part, so y is equal to the positive square root of 2 minus x squared. So that's going to be equal to square root of 2 minus x squared dx, and we're going to start where? At 1, and go to where? Square root of, because what's the radius of this circle? 2. Well, r squared is 2, so it's the square root of 2. And you have to add these together. I don't know about you, but I like, if I can, check my answers so I feel better. And there's a couple ways to do it, I think they said. That's the way I did it. The other way to do it is to use some geometry. This is AB material. This isn't BC. So that's 3 points. I don't know if they did a double bubble on this one. Okay, so you have to do one for each of it, and then one for the limits on the integrals you don't have to integrate. And you have to add them. Okay, next part. Set up an integral, an expression, to get the area of R, but I want it with respect to Y. So you know what I'm going to do? I'm going to erase my picture here, and I'm going to slice it this way, which is much easier. This is the x value on one curve. This is the x value on the other curve. So the area for B, I've never seen them do volume, not to say it's not a first, is x1 minus x2, and my differential is dy. So I want the y values. And what do the y values go between? They start here at 0 and go up to 1. I think they wanted to do this to you just to see if those polar curves would bother you. So let's see. I want this x value first, which is x squared plus y squared equals 2. So x squared plus y squared equals 2. So x squared equals 2 minus y squared, and I want the square root of that. So it's from 0 to 1, and it's square root of 2 minus y squared minus, and then I have to find the other x1, which is x minus 1 squared. I'm going to copy it here, plus y squared equals 1. And I want to solve for x. So x minus 1 squared equals 1 minus y squared, and then what do? Square root. And again, I want the positive one, so I won't write down the negative because I don't want the one underneath. So x equals 1 plus that. Yeah, it's ugly looking, but since we don't have to integrate it, no big deal. So this is 1 plus. Do I need the parentheses here? You always need parentheses because that would change the answer. I can't read that, so let me fix that. It's 1 plus that. If you don't put the parentheses here, then you actually are doing minus, and that's not true. Well, geez, that's all AB stuff. There's no polars there at all. It looks like a polar. Yep, I have 1 minus. Oh, if you distribute, did they distribute? No. Oh, no, I got to be the top one. Did I make a mistake there? Yeah, I made a mistake here. What did I do? I might have the wrong one. This might be the minus one. Well, how can we check? Because which one do I want? I want this one. Oh, yes, maybe. Because I want to go through the origin. So if I put in 0 here and 0, 1 plus 0 is equal to 1. I got to check that. That's what I got to do. So this is plus or minus. So let's test 1, 1. So 1 minus 1, that's not going to work either. Oh, I know what it is. It's because if it's this part of my parabola, well, it should be still the plus. Let me think about that. Lost a point, darn it. Okay, the polar equations of the circles are given. Set up an expression with respect to the angle that represents the area of R. So now, this one's tricky. I want this region. So where's my angle going to start? It's 0, and it's going to go up to here. So how are you going to find it? Hey, Sam, how are you going to find that? I want this piece right there, right? I have to integrate from 0 to, what angle is this 1, 1? What angle? The tangent of theta equals 1 over 1, so it's pi over 4. Then, that's for this circle. Then I have to integrate this one, the other one, from pi over 4 to what angle here? I want just this little crescent. What angle is this? Where R is 0 here. 2 pi over 2. To me, that's the hard part. So I have to integrate. I got to figure out why I did the other thing wrong. Okay, it's 1/2 R squared from 0 to pi over 4. I better get the right graph. see, I wanted this big circle. That was r equal to 2, right? Square root of 2. So that's square root of 2 squared. D theta. No, just I got stuck with a sign, that's all. Then I got to figure that out. And then the other one, you're going to integrate this one, which is 2 cosine theta. 1/2 2 cosine theta squared d theta from pi over 4 to pi over 2. Worth 3. 2 for other errors. Okay. So, do I need to give you directions on what you should study? You should be working on all the polars. There are other polars here. There's the one we did for the assignment. That wasn't that one. You should do that one. That one's not hard at all. It looks terrible. You should, if you have done that one, that's 2005. You could go back and study it. And you should also go through all the multiple choice of all the polars. And that was it, I think. That's all I've got. Now, Princeton Review might have some help with some extra practice with polars. I don't know. That I haven't seen. And then there's one polar in all of the other free response multiple choice questions because they were not free response questions on the exam. Tomorrow, we will do vectors. It won't take long to talk about vectors, and we'll do lots of problems on vectors. Those of you not doing the problems, don't assume that you will do okay on the exam.